Okay, so we're going to kick this off with a video about conditional probability. Now, essentially what's going on here is you have some sort of sample space. Oops. So this is the set of all possible events that could possibly happen in our world, right? And we're going to first divide that space into two parts. Okay, so we'll call this A, this part over here, A, and we'll call this part over here not A. So we're going to actually use some notation here, which is going to call that A complement. Now, so we're going to go and we're going to actually sample one event from this population. So we're going to pick something from this whole sample space. And either that event is going to be an A or it's going to be a not A. So in conditional probability, we already know which side of this has come from. So either it's come from the A side or it's come from the not A side. Now, this same sample space can also be partitioned another way. So let's draw another line going this way. Okay, so these are the events that are B, and these are the events that are B complement, which is not B. Okay, and what I want to know is if I know, so I know the thing that I have sampled is in A, what is probability that it is also in B? So we're going to write that as the probability of being in B, given that I know it's in A. So this is our notation. Probability of being B, given that I know it is in A. Okay, so the best way I think to look at this is to try to understand this with a specific example using a two-way table. So I'm going to kind of clear this all out, present us with a two-way table, and try to get that example. Okay, so we have a two-way table here where we have an example of the population is being broken into two groups. Right, it is being broken into male and female, and whether or not they have pierced ears. Okay, so we want to know, let's say we want to know the probability that you know that you have somebody who has pierced ears, right? Sorry, you know that you have someone that is female. You know that you have a female student. Then we want to know the probability that we have selected someone who has pierced ears. Okay? Okay, so we have two events here. The first event is that we have chosen a female student. And the second event is that we have chosen someone who has pierced ears. So our first move here is to establish like what are the two events. Right? One is that we've chosen a female student. The second one is that we have chosen a student that also has pierced ears. Okay, so what we're looking for is the probability that given a female student, what is the probability that we also found a student that has pierced ears? So we're looking for the probability of B given A. Okay. Now I can calculate that given my two-way table here, right? Because I'm given that I have chosen a female student. So I've now choosing out of the 88 female students, and I'm looking for a student who is actually is in that group that also has pierced ears. So 84 out of 88 of those students are in that situation. So let me bring up a calculator here. Okay, so this is a pretty straightforward calculation. So I'm going to say I'm going to take 84 and divide that by the 88. So that's the 84 female students that have pierced ears divided by all of the female students gives me this 0.95, roughly 0.955. So we're going to say that that's approximately a probability of 0.955, which means it's about 95.5% of the time that I choose a female student that I do find someone who has pierced ears. Okay, so let's note that this is very different from the probability of like having chosen someone who has pierced ears that I get a female student. Okay, so let's take a look at that. So given someone, so the given part here is now that they have pierced ears, right? What's the probability that I get a female student, right? So how many students have pierced ears? Well, 103 of my students have pierced ears. And of those, it's still the same 84 that are both female and have pierced ears. So that's going to be something that we're going to note later on, is that when I flip these, the numerator stays the same. It's the denominator, the population that I'm taking it out of, is actually changing. So let's figure out what that probability is. Let's take 84, divide that by now 103 students, right, who have pierced ears. And that's going to give me 81.6, basically. So 0.816, which is 81.6% of the time. So there my probability dropped, right? It's not the same. If I'm given a female student, the probability that I find someone that has pierced ears is around 95.5%. If I'm given someone who has pierced ears, the probability of me finding someone who is a female student is going to be around 81.6. All right, so in the next class, we're going to do some work with these conditional probability problems, and we'll go from there. This is the major theme for this unit. All right, thank you.